So today we'll be talking about deploying, scaling, and managing production machine learning workloads on vSphere. We are happy to have a partner, Algorithmia, with us. They have ported their management platform, the operations platform for machine learning onto vSphere, and so they'll be speaking about it today. And I am a staff solutions architect here at VMware. And then let's have the others introduce themselves. Neeraj?
Hi, Neeraj Arora. I work as the applications platforms architect with the Office of the CTO. And we collaborate with a number of ISVs in the machine learning space to bring the best of breed solutions to you.
Okay, Algorithmia people.
Hey, I'm Diego Oppenheimer. I'm the CEO and founder of Algorithmia.
I'm Hernan Alvarez. I'm the VP of Product of Algorithmia.
Okay, so today in today's agenda, we're going to talk about machine learning trends, machine learning architecture, and how the VMware infrastructure provides a great platform for it. And then we'll then pass it on to Algorithmia to talk about how their ops platform works and integrates with vSphere. So let's get started. So this is one of the things that our CEO, Pat Gelsinger, speaks about quite often. Machine learning is the most important new workload to emerge in the enterprise in the last 10 years. And it's important for us to be able to use it in an efficient manner in a virtualized environment. And that's kind of what VMware provides. And if you look at the AI ML software market, there is a tremendous growth potential. So that's what's driving this market, and VMware plays a very important role in that. So, if you look at machine learning, it is a small piece of the big puzzle. So it's in the area of data analysis. So, but but it does play a significant role because it has transformed how data is used, and the compute environments have evolved in such a way that now machine learning training provides a lot of capabilities that wasn't there in the past. Even though the area of artificial intelligence has been there for many, many years, machine learning only has recently evolved because of the compute capabilities that have recently evolved. I'll pass it on to Neeraj to talk about.
Thanks, Mohan. So in solving that machine learning puzzle that we saw in the last slide, when you got into the market, you are inundated with the number of options. And to try and simplify this, VMware has come up with an ML solution stack vision. Mohan, would you move to the next slide, please? So VMware's ML solution stack vision is divided effectively into three major components. So you've got the data platform, and VMware has solutions there to assist you, either by ourselves, or we can collaborate with Dell or a number of other storage vendors and storage solutions. There's the ML and AI platform, which is a lot of open source and proprietary frameworks that either work with a solution like Tanzu Greenplum, or they can be deployed independently on VMware Cloud Foundation, on VMware Tanzu, and serve the ML AI capabilities to build and train your models. And then comes the MLOps platform, where VMware is collaborating with a number of ISVs, is supporting a number of ISVs. And here we have Algorithmia. They'll talk about the MLOps platform in a bit, which helps you operationalize the machine learning artifacts created using the ML AI platform, depending on the data platform. Next slide, please. So before we, Mohan, next slide, please. Before we dive into the presentation, the guts and meats of the presentation, let's understand the problem statement. So problem statement here is facilitating the data science process. Now, the data science process starts off, after a problem definition and so on. It starts off with data collection, goes into data pre-processing, exploratory data analysis, and so on, to the point where a model is built, it is deployed, and then consumed by applications or users in real time or in batch processing, and then monitored for effectiveness. Now, this process is not very different from software engineering process, right? So the software engineering process essentially does this with software. We are doing this with mathematical models, which depend on data. So where software engineering process depends on code, your ML models depend on data. Where software engineering process, the code manipulates the inputs and outputs. In the machine learning process, your mathematical models are built by manipulating the data. Now, going back to the last picture had data platform, ML AI platform, and MLOps platform. The data science process is cleanly supported by these three platforms. Next slide, please. So as you'll see, a number of these processes occur mostly together in practical implementations of an ML solution stack. And that becomes the basis for the VMware statement of the ML solution stack on how we are trying to simplify this for the people that are consuming, for our customers and partners. So from here, we can now imagine an infrastructure platform, an ML architecture that essentially takes these three components, the data platform, the ML AI platform, and the MLOps platform, and places that in a VMware solution stack. Next slide, please. So there you go. So you've got the data platform, ML AI platform, and MLOps platform, which in the last diagram, in a few slides ago, you saw that sitting on VMware Cloud Foundation. But in an entire architecture space, in the VMware architecture space, it collaborates and works with a number of tools inside the VMware ecosystem, works on either VMware Cloud Foundation or along with that on Kubernetes, utilizes a number of hardware and infrastructure components in your data center, and delivers the best of breed ML experience. And from here, I'll pass it back to Mohan to talk about the modern compute infrastructure, which supports the three components of an ML architecture. Thank you, Mohan.
Yeah, so if you think about the modern infrastructure now, we have traditional virtual machines. That's kind of a bread and butter of VMware. And then now we have Kubernetes showing up quite a bit, and then the serverless architectures as well. So these are this is the reality of IT infrastructure, with all these components coexisting and needing to interact with each other. And that's kind of what VMware vSphere 7 with VCF4 brings together, right? We announced the support for Kubernetes natively in our platform with vSphere 7. And the world of the developer who is able to interact directly with the infrastructure with Kubernetes is now also the same world as the IT operator. So the IT operator is able to also manage the infrastructure that the developer is interacting with. And that's what VMware vSphere 7 brings together, and it is really adept to the new environments that most enterprises now have, and VMs and Kubernetes can now coexist with each other. That's what this brings together. And the traditional components of the VMware SDLC has now become the VMware Cloud Foundation, and all the components of compute, storage, and networking have all been virtualized and software defined. So just to kind of bring together some of the use cases that are commonly supported with VMware is that, and we support accelerators like GPUs, and the GPUs are one of the critical components for machine learning. And so we have all these different use cases for data scientists, researchers, HPC users, developers. And you see that we offer different ways of and mechanisms of accessing GPUs. And so that provides the flexibility within the platform for machine learning. And last but not least is that we bring it all together. You have VMware Cloud Foundation, we have concept of compute workload domains, we have concept of integrating all the GPU resources into a separate cluster and the ability to kind of bring it all together. And all of this is managed in a traditional vCenter environment and also what we call as SDDC manager with the VMware Cloud Foundation. So with this, I will stop sharing and pass it on to the Algorithmia folks.
Great. Thank you very much. I'll take it from here. So give me 1 second. And if I can get a thumbs up, if you can see my screen. Perfect. Thank you. Great. So thanks very much for the introduction to the VMware team. And so kind of what I will do right now is a little bit of an overview of Algorithmia, some of the architecture overview of VMware on VMware, as well as some performance and usage highlights, and then leave some time at the end for some Q&A. So feel free to use the chat box to send in those questions. Happy to answer them. So at the core of it, as Mohan and Niraj introduced, when you start looking at how you're industrializing machine learning, how you're productionizing machine learning inside an organization, there's a level of different components. And what we provide is what I call the last mile. How do we actually deliver these machine learning models in a repeatable, scalable, and secure way to the business applications that are going to go actually and run those? So at the core of it, introduce what we consider, we talk about Algorithmia as being a machine learning operations and management platform. Another way to think about it is we productize the relationship between developers, data scientists, and DevOps, or the IT organization that's managing the VMware loads. And this really looks at the abstraction between models, infrastructure, and data. So our mission really is simple. It's to empower every organization to achieve its full potential through AI and machine learning, and deliver these kind of intelligent applications, which are the future, as Niraj pointed out at the beginning of the deck. So when we think about machine learning application, one of the things that if you're going to take anything from today is that machine learning and production machine learning are very, very different. There's very different considerations. When you're looking at production, meaning how am I actually running these models, predicting it, having real business applications running against them, I have to start thinking about things like cluster orchestration, API management, utilization of GPUs, container management, load balancing, distributed parallel processing. And what our platform does this very seamlessly on top of your VMware stack. And so that is the core component that Algorithmia does, is kind of give a really, really good experience for both the IT persona, but as well as the DevOps and the data scientists who want to just get their models and pipelines out into production and integrate that into their general workloads. So one way that we like to think about the development lifecycle is, there's training and there's multiple iterations and data science and iterations around that. And then we deploy those models, manage them in production, connect to your different data services, build out your pipelines. And then there's the operational aspect of how do I run the model? How do I scale the model? Who's calling it? When? With what data? And monitoring their performance. And this is a cycle that never stops. This is a continuous life cycle. New model gets deployed, it gets run, you now connect it, new data comes in, have to go re-trigger the training of the model. So there's this continuous life cycle. So if you're accustomed to the traditional kind of like build, deploy, test of an application, this is very similar, except it happens much more quickly. So what we see is a much faster iteration. And it's extremely important to be able to provide governance and security operations and regulatory compliance, because in a lot of cases, the data being used in these machine learning applications is PII or sensitive information in regulated industries. So one thing to think about is, to be able to use this data in a smart way, in a predictive way, we also need to secure and govern it. And so this is why the combination of the VMware and the tooling around VMware plus Algorithmia provides an extremely good solution to be able to do this in a secure, compliant, and governed way. So we like to think about ourselves as we solve ML production. We allow you to, as Niraj showed in the beginning of the deck, use a variety of different tooling around how do you train models, what libraries you use, what data you use. So this is very similar to thinking about how we want to allow a developer to use the language, IDEs, whatever tools they want to do. But once you actually are going to start moving these things into production, you want to standardize and start solving around that. So the Algorithmia platform will help deploy those models, catalog them, run, validate their versions. It will actually start being able to deploy into the cloud or on-prem, via VMware, do continuous integration, and then provide that governance and security layer across the board. So if we want to, dive a little bit deeper into, kind of what it looks like in the feature set, and we'll get a little bit into the architecture in a couple of slides, but, the idea is to provide a single environment for continuous integration and deployment of machine learning workloads. The idea here is that we can actually support data scientists, ML engineers, application developers, DevOps, the entire set of people that would be responsible from taking a model from ideation and build out to an actual application that's running, and do this in a way that can actually optimize performance costs for the business requirements. So our platform, Algorithmia, runs both on premises as well as multi-cloud. Obviously today we're talking about kind of the VMware implementation, which again, we work in some of the major clouds on their VMware implementation, as well as on any of the partners here that are talking. We can actually run the entire platform in your implementation of VMware. The platform itself has a couple of different components around training integration, which means integrating with your training systems for machine learning, connecting to your different data services, being able to register those models in a searchable and usable catalog that can be reused, provide a way of doing very quick model pipelining. It's very rare to see a machine learning model live on its own. They usually exist as part of pipelines. And then do model management, which is versioning, around the APIs, the data, the documentation. We move into the operational aspect of it, which is, okay, how do we actually launch instances of these models? How do we actually call it? What's the API look like? How do we do authentication and security around it? How do we manage the scale out over the infrastructure under it? Obviously, in this case, connecting directly into vSphere and being able to provide that acceleration and scale out up and down, and then providing a set of tools that allow you to monitor and report everything that's happening across. So this is things like the statistical inference monitoring inside models, as well as cluster health and different metrics and usage metrics that are important inside any sort of production system. And then again, obviously, all of this needs to have a high level of governance and security, which is required for the kind of sensitive workloads. So to place a little bit the MLOps workflow so that everybody kind of gets a good idea of how this, how this actually lands. So you'll likely have a number of data management systems inside your organization. This is your ETL pipelines, your feature stores, your data lakes. These are all your systems of record where your data is actually being provided. You're likely going to have in an organization multiple different ML data science training platforms. And so these will actually be, either open source toolkits or actual platforms that your organization has bought where you can pull that data, train models. At this time, we provide an API interface so that you can automatically push those models from whatever tool you've chosen directly into the Algorithmia platform. So build and publish those models. Once inside the Algorithmia platform, those models can be deployed, operated, and secured around that. And then the consuming applications can directly tap into the MLOps platform for running their workloads. Now, all of this, can happen on a continuous and automated basis over time, which is the important thing. What we're setting up here is a process for industrializing ML inside an organization so that this is a repeatable, secure, and fast way of actually getting applications that are run by machine learning out there. So one thing that we like to think about Algorithmia is that we're an integration first platform. What we mean by that is because we've specialized in this, what we call this last mile, the MLOps piece, it's been extremely important for us as an organization and as a piece of software to support the widest variety of integrations. So we really mean it when we're flexible. We allow you to use almost any data science tooling, bring in a model from any of the tools that you want to be building, connect any of the monitoring services that you're using inside your organization, provide any of the data services that you're using in your organization, use your source code management systems that have already been implemented at a enterprise level, the widest variety of frameworks and libraries for doing machine learning, and then the widest variety of compute resources around the platform. What we strive to be is a consistent experience across your enterprise for doing MLOps, and in particular, then being able to call it from any sort of application that exists out there. This gives the maximum amount of flexibility, but also the maximum amount of future extensibility for organizations that are adopting MLOps and being able to, again, the goal here is time to value of machine learning and industrializing the ML workloads. So let's quickly go through kind of like the breadth of the platform so you can see a little bit more about what we mean by exactly around MLOps. So the core around training integrations is allowing you to use any tool that you want for machine learning training. So Niraj put some of the, kind of the stack that VMware has already looked at, direct integration with that, but also future flexibility for future pieces of training around that. We can run any Python, R, Scala, Java, JavaScript, Rust code that would allow you to go do that and have the widest variety of frameworks supported. This also allows you to create native data connectors inside the platform. This means connecting to those data sources that you already have, either existing or future data sources, and being able to use the actual implementations that you have around security, authentication, and permissioning around those data sources that you've already established at the enterprise level. Once you're actually deploying a model, it's the action of actually packaging the model, all its dependencies, integrating all of its documentation, and providing the path and the kind of governance to actually getting that model deployed. This means doing unit testing checks. It means doing governance checks around how you actually build that out. Once that artifact is deployed and running as a as a service, being able to search through it, being able to tag it, and do discovery inside that experience. We talk about algorithm serving or prediction or the actual calculation that is actually being done. So this is how you actually do the computational aspect of running these models. So we have what we call a machine learning aware serverless platform that is natively built into the product inside, in our VMware implementation. It works over CPUs and GPUs. It's an extremely efficient way of doing scaling, but also allows you to do composability between functions around that. And then finally, the model management aspect of it, which is how do I actually control access, ML lifecycle, version management, do A/B testing, rich access controls around the platform. These all become key components of how you're actually doing evaluation and performance. So one of the things that you want to do is, once you deploy a model, you want to automatically create the API generation for consumption. Again, what we want to do is the quickest way for an application to be able to consume it. So as you deploy these models, being able to provide a specific language and framework implementation and making it ready for consumption. Machine learning model like the pipelines are going to have a lot of heterogeneity. What you're going to see is different framework versions, different Python versions, different CUDA dependencies is a good example, NVIDIA. Algorithmia abstracts that and takes care of all the drivers, takes care of the language dependencies, takes care of the framework dependencies, so that your data science team, your application team can actually work directly on the actual, what I call the intelligence part, and not having to deal with, how do I actually accumulate all these different frameworks, work across the board. We abstract that for you. Automatic versioning and permissionings around security, versioning, packaging. This is all pieces of the platform that come built in as well as part of that MLOps platform. Pipelining, super important. As I mentioned before, models don't live in isolation. What we actually build is different pipelines. So there's a good example here of we actually want to create a pipeline around scanning documents, doing OCR, identifying language, understanding if it's in English or not. If it's not, translating it, then doing some vectorization and then a sentiment analysis. This is a pretty typical pipeline that we would actually see in a natural language processing world. So one of the things that Algorithmia allows you to do is actually you can see every single piece of the pipeline is actually versioned. I can actually sub out any part of these models at any given time, update the entire pipeline, swap models on the file, and actually maintain those versions. This becomes an extremely easy experience for the application developers and the builders who are doing this. And again, this can actually all run under the scenes in a really effective way where the platform is actually orchestrating the VMware VMs to be able to actually do this in the most efficient way possible as these dependency graphs get built out. So when we go into operations, we talk about how do I do approval process for publishing models? How do I do access controls and permissioning? Can I actually evaluate these models for performance? And we provide a set of tools that actually allow you to do that directly inside the platform. When we look at infrastructure management, again, this is where the partnership and the direct integration with vSphere becomes so important. We can do things like fully automated infrastructure, service component redundancy and high availability, making sure that we're actually, doing multiple cloud supports as well as on-prem, and actually doing those hybrid models, so that I can actually have one consistent experience that works across the cloud, around on-prem, and providing a full system administration for all of that. And then what I call the who called what, when, with what data, and why. So this is extremely important in ML workloads. Honestly, it's important in any DevOps workload to be able to have observability, but in particular in machine learning, how do we actually do the metrics and customizations? How do we understand who's calling what components, what the cost of those components are, and actually being able to do the model performance around ops and inference. So these become extremely important aspects of understanding everything that's happening inside the organization and inside that MLOps platform. A lot of this stuff is event-driven, programmability driven. So everything inside, Algorithmia, we have a very pure UI, but you can actually look at everything's programmatic. So you can access everything through APIs and automation. This means that you can start doing things like event listeners and triggered schedules. You can integrate it directly with CI/CD pipelines. And you can actually do complete automation of retraining and publishing solutions by integrating with our workflow. I talked a little bit about the infrastructure modeling and around how that customizable dashboards experience, health metrics across this. So we use a lot of the data that we can actually get from the vSphere components under us, provide a new set of metrics and view of that, and actually allow the administration of the platform to be extremely easy with a lot of observability, so you can actually understand what's going on at any given time. So one of the things that we like to talk about is how you can actually do this serverless or functions as a service implementation of inside of machine learning. So it's just, if you think about prediction inside machine learning, using functions as a service is a killer use case because it allows you to spin up and down very quickly these models and run it very efficiently. And so directly inside vSphere and the VMs, as we generate those VMs, our model orchestration layer will actually those VMs in an extremely efficient way, understanding those dependency graphs and do it in a smart scheduling way so that you can actually use the components under you in the most efficient way possible. And this is actually shown, and I'll show some performance metrics that we can actually inside VMware implementations show much higher performance than on traditional clouds, as well as much more efficient compute and cost when running massive workloads for machine learning. I talked a little bit about model performance and monitoring. So every single model that you actually publish automatically will start participating in what we call an operational and inference metric. This allows you to actually connect any sort of your IT ops observability dashboards directly, not only to the platform performance, but also the model performance. So getting that flexibility and understanding, hey, why are things going wrong? What's going on there? But also allowing me to use what I already have implemented inside my organization from a IT ops, kind of application performance management system. We can directly integrate into that as well. And then finally, which is very important, around governance and security. So we will actually allow you to manage the entire lifecycle through tools like model and data access controls, user group access controls, AD syncs, rich API controls. Using things like your own code, so source code management, private Docker Hub and private dependency measures, custom provided OS images, all these things in high security environments that would actually be required from a governance perspective and IT perspective, we actually directly integrate and allow you to do from an MLOps platform. And then from a security, everything's encrypted at rest and in flight. We can actually allow you to do unique pairings between models and authentication keys so that they get their own computational path. We have advanced network security integrations, again, directly into vSphere, allowing you to use things like private and public certificate authorities, SSO authentication, and if you require it, air-gap deployment options, where there's absolutely no network available to the to the platform, and it can still run, as well as kind of key management integration. So to kind of deep dive a little bit into the ML security and governance. So Algorithmia Enterprise obviously sits on top of vSphere. We have a Kubernetes cluster internally. We provide audit controls for every single interface, SSL encryption at every single interface as well. Provide that ability to using private CA authorities. And then we actually do kind of like isolate users, models, and groups or organizations inside your enterprise, as well as providing you individualized security options for the different model languages, frameworks, and the different data tools. So everything's extremely granular, allows like IT teams to actually really set these up for success in the highest restrictions around security if those are required. And just to kind of land a little bit how this might look inside an organization, this is just a different way of looking at the same kind of diagram. You might have your enterprise data infrastructure, your data lakes, data warehouses, application stores, external stores. You might have some of your AI ML infrastructure that Niraj talked about, where you're doing some of your model training, data engineering. And where Algorithmia comes in is actually isolating this piece right here around enterprise ML security from an MLOps platform. So how do we do the ops and infrastructure? How do we do the deployment, data sources, so that we can actually create all the business decision systems, application systems, and edge services that call into that, and have that full isolation around monitoring compliance that is required. So to kind of remind everybody a little bit about kind of what we were talking about, and in terms of the suggested ML architecture that VMware and Algorithmia are working on together, you are going to have your VMware Cloud Foundation, kind of like how Kubernetes is actually like running, your different data platforms, your MLAI platforms, and obviously your MLOps platform that works across these planes, so that at the end of the day, all that matters, getting your business processes, business services, business functions, and risk management running off of machine learning, which is kind of the future of all these applications. So quickly, I'm going to go through an overview of what exactly how we run this on VMware. So a typical Algorithmia cluster is composed of a couple of core platform VMs and services, CPU and GPU work nodes, databases, object storage, and then we usually do redundancy and high availability. So usually we ask for 3 physical vSphere host machines, and we treat them as availability zones for high availability. So inside VMware Technology Foundation, we're working with vSphere and SX, vSAN. These are the components that we actually look at to be there to be able to lay down our platform internally. Inside that, if we kind of abstract level from the high level functional components that are inside the platform, you're going to see source control and development tools. So multi-language support, pipelining, those embedded Git, source code management, CI/CD automation. We have the algorithm model management part, registry of models, version of access management per algorithm, algorithm monitoring analysis. We have data access, which we talked about those data connectors, and then we have the algorithm execution piece, which is version REST APIs, CPU and GPU worker machines, scheduling, and advanced, event-based invocation. When we look at kind of like the network and how this thing works, you'll see a set of the access outside of the Algorithmia network, load balancers, general purpose nodes. We talked about that CPU algorithm execution pool, the GPU algorithm execution pool, object storage, relation of databases. So this kind of gives you an idea of how this network topology and system topology lands inside that MLOps platform. And to give you an idea of scale, so we run algorithmia.com. This is the architecture and platform that we run there. We have over 130,000 users there, over 140,000 versions of these models. We do about 230,000 builds of models, and 128,000 published endpoints. So routinely, we're doing over 200 requests per second on heavyweight ML models, millions per day, and supporting all of those things. So when looking at ML platform, latency and throughput becomes super important, and the system's been built for scale. And actually, the implementation on top of vSphere has given us really, really good performance for being able to provide the lowest latency and the highest throughput possible. And one of the interesting things that we did is we actually, Algorithmia has actually has performed even better on the VMware hardware and the VMware implement vSphere than actually directly on cloud providers. So we run on all, but one of the interesting things is the efficiency and throughput that we've actually seen in the implementation through vSphere, either being cloud, VMware in the cloud or in one of these services, has actually been quite impressive in terms of the scale out and performance we're seeing. So super excited to having been working with the VMware team on this. And really, as I said, throughput and latency are super important to us. So being able to hit these metrics is key. And then one of the things that other things that do important, again, we're talking about production systems. So feature sets that are built into the VMware stack, like vMotion on live ML nodes, being able to actually move things around in clusters, generating loads, migrating that, a CPU workload, migrating in Kubernetes component, maintaining uptime and SLA. These are things that all work beautifully inside this ecosystem and are extremely important for large scale ML workloads. Again, we're talking about production where SLAs, redundancy, high availability becomes extremely important. So being able to actually integrate your MLOps platform with these feature sets is a key component for success. So with that said, I wanted to open up the the session for some Q&A. I'm happy to go back into any components, and I'm already leaving my email here. If you have any questions around that, please feel free to email me. We'd love to talk to you. We'd love to talk about with the different partners here and how we can work together.
Great, Diego. Thank you so much for giving your email. I know a lot of times after a session, partners do come up with questions, so appreciate you doing that for us. We're going to stick around for a minute, and just because we are ending early, we'll just stick around for a minute and make sure if you have any questions, you have time to, again, put those in the Q&A. Mohan, I'm going to put you on the spot, but any last minute thoughts or comments that you want to do as we wait for any questions and wrap up this morning?
Sure. Thanks, Teresa. So, Diego, amazing presentation. And this is Algorithmia is a great example of how partners can leverage the VMware platform. And they've layered on top of us and provide such a great MLOps platform. So this is a good indication on how partners can work with VMware to enhance their offering. So, and this is a great example.